Welcome everyone to the Maui Advanced Technology Research Center, the Michaelani building. I'm Dr. J.D. Armstrong. I'm the Maui Technology Education and Outreach Specialist, and one of the things that I get to do is put together these talks, and thank you for all coming. This month we have returning from Oregon, Bernie Taylor, who is a naturalist and author. Last year he gave a program called The First Astronomers. That's on our YouTube channel. You might want to look that up if you enjoy this talk, because you would probably enjoy that presentation as well. In that program, Bernie explored astronomy in the Paleolithic caves of Europe. His program today is Are We Alone in the Cosmos? And Biological Time and the Drake Equation. So this will take us even further back in time and how we began as a species. In this journey of discovery, he will pose the ultimate question of if there is other intelligent life in the cosmos. Bernie is the author of Biological Time and Before Orion, Finding the Face of the Hero. So let's give him a nice Maui welcome.
JD, thank you for the introduction. And last year when I was here, we talked about Paleolithic astronomy. We went back about 34,000 years. And we saw the constellations of the ancient Greeks as projected onto the cave walls, and about 20 of them in total. And at the end of the program, someone asked the question of what was before the archaeoastronomy or these Paleolithic astronomers? Where did it come from? Today we're going to answer that question, at least go further back in time to where it all began. And when we look at it from a different perspective, we're going to look at the perspective of biological time. So how do plants and animals tell time? We look at a clock. We look at the sun. We don't look at the moon. How do plants and animals tell time? And on our journey, we're going to begin on the beaches of Southern California, where in the late spring, the California Grunion swarms up on the beaches, and they swarm up on the highest of the high tides. They lay their eggs. And then the male fertilizes the eggs, and he catches that high, so that the next high tide back. And so the eggs are high enough on the beach that they're protected from continuing surf. And those high tides are tied to the full and the new moons, the relationship between the sun, the earth, and the moon. So it's unique to our time and our place today. Okay? The juvenile grunions will... So if the eggs drop on the new moon, they will hatch 15 days later, or 14, 15 days later, and then catch the next high tide at the full moon back out into the surf. So it's timed, their entire life cycle, to these tides and the sun and the moon. So it's not real. It's a terrestrial and a marine animal at the same time, because they have that cycle. Well, that couldn't have happened many millions of years ago. Maybe tens of 20 millions, whatever the time period is, because the moon is moving away from the Earth, 3.8 centimeters per year. So in the many millions of years in the future, the clock for the Grunion will be off. The tides will be different, or the sequence or the duration between those tides, those high tides at the new and the full moons, the spring tides, will be in a different duration. And the juveniles have to either grow faster or slower or something like that. And there'll become some variation with the Grunion species. They will become a different animal than they are today. So we're going to keep that concept in our minds as we go through this program. That life itself on this planet, at least with the Grunion, is timed to a relationship between the Earth, the Sun, and the Moon, as it is today. People around the world, hunter-gatherers, have this in their traditions. The Yami people of Taiwan, across the ocean Pacific, from here across the Pacific, have the Flying Fish Festival in the springtime. The flying fish appear, it's a migratory fish, and the Yami go out with their torches. And they raise the torches, and when they see the flying fish, they catch them, they bring back to have a flying fish ceremony. They go out to look for the flying fish 12 lunations, or 12 new moons, from the last time the flying fish ceremony began. And if they go on that flying fish ceremony, so that day to catch the flying fish are not there, they wait one new moon, or one lunation, and then the flying fish will appear. And that resets their calendar for hundreds of species of fish and other marine life. that are in sequential order. It's all timed to the flying fish. And this tradition goes back to time immemorial for the Yami people. And of course, you've seen this flying fish here in Hawaii. You might be on a boat and it falls on your deck, right? Near Seattle, Washington, I'm from Portland, so just north of me, we have the Tuolip tribes. And they time their first salmon ceremony when the first salmon appear by the white pine butterfly. And in the springtime, they send out scouts to look for the white pine butterfly. And when the scouts find that white pine butterfly, they then go back to the longhouse and they wait for the highest of the high tides. Because they have these huge canoes that are set up by the longhouses. The easy way to get in the water is on that high tide, in the same way as the Grunion time their own migration or their own dropping of the young. And so after the white pine butterfly appears, then the next spring tide, they have a ceremony. They send the canoes out into the estuary. They catch the salmon. They bring it back to the longhouse, and they have a first salmon ceremony. And at the end of the ceremony, they put the remains of that salmon into the ocean or the bay to invite other salmon to come. And that's in their tradition since time immemorial. We can go south to Northern California to the Uruk Indians, and how the Uruk timed fish weir, which ran across the Klamath River, was for summer steelhead was 6 new moons after the winter solstice. It took them about 15 days to build this elaborate fish dam. If you ever tried to build any simple project across water, it's difficult because the water moves it. And this was a weir where the steelhead would come up when they would trap them. So it's timed to the sun and the moon. In the lower Columbia Basin where I live, between the states of Oregon and Washington, the Native Americans once fished at Celilo Falls. Celilo Falls is now flooded over. It's just huge reservoirs. But we can see what it looked like about 70 years ago. And then if you go to ask the Native Americans, when did the salmon run, they're going to tell you a story. They're going to tell you this myth about the coyote and the swallow sisters. And the myth, somehow the coyote created the Columbia River Gorge, and the swallow sisters precede the salmon by 4 days, and it's counted by the 4 swallow sisters. So if you go ask the Native Americans about salmon biology, they're going to tell you this story. And I heard this story about 20, 30 times before I realized that maybe there's something in the story. That they're saying that the salmon and the swallows are migratory, that one precedes the other. And you can time off them. And the same as the white pine butterfly. In the Lower Columbia Basin, Chief Tommy Thompson, the last of the great chiefs, he also timed. He started looking for the swallow sisters, or the swallows, based on the sun. And he had a longhouse that was faced due east upriver, and he had a pole, and on the top of the pole he had a bird that he carved, and he looked at the shadow, as in a sundial, off the top of that bird that told him the time of the year. And he believed that the great Almighty was speaking to him through the shadow of that bird. And the same, remember Indiana Jones with the staff, and kind of the staff of Ra, of Moses, same idea. That predates the movie, but not Moses. And the Nez Perce of Idaho, as Chief Joseph fame, also have a more elaborate calendar. And their calendar is all the different lunations. We can see 12 in all. And we can see the time of the blueback salmon run, when the salmon reach the canyon streams to spawn, when the fall salmon, which would be Chinook salmon, come up the river, and the season of the fetus of the womb of the deer. So we're not just talking terrestrial animals. For marine animals, we're talking terrestrial animals as well. And in the same way as the Yami calendar of Taiwan, that one precede the other, we find that with the Nez Perce lunar calendar for all these plants and animals. And of course, this goes back to time immemorial practice. Further, let's say north, the Thompson Indians of British Columbia have a calendar that's timed off of the black-tailed deer, which was their dominant animal. And on there, they reset their lunar calendar on the rut of the deer. And all the other animals fell into place. And so following that, we have the bucks shed their antlers, the deer drop their young, so there'd be a time gestation period, and they have the salmon as well. And this was, of course, goes back since time immemorial. And these Native Americans didn't live in one specific place waiting for the salmon to come, is they migrated to different areas, from high and low grounds, and the rivers and the plains. So the lunar calendar was their clock to gauge their place in time and space. Across the Pacific in what's called Paleoasiatic people in Siberia, the Chukchi. And the Chukchi time their entire life off of the reindeer, or caribou to us. And there we can see all the old buck moon, the cold udder moon, the general udder moon, the calving moon, and the rub of the antlers moon. And so they didn't travel to the salmon and to the white-tailed deer and all these other places they moved with the reindeer. That was their lifestyle, and it still is for many Chukchi today. But they have a lunar calendar that sets everything in motion. And if you're going to live off the life of a caribou or reindeer, you're better off living off their calendar and not the calendar we have on our walls today. It would make more sense. So is this possible that you could have these large ungulates with solar-lunar rhythms? There was a study done on the wildebeest in Tanzania, and they found that they looked at the dropping of the young, the game wardens calculated the dropping of the young, and a field scientist, Professor Anthony Sinclair from the University of British Columbia, back calculated the gestation period and found that the start of the rut each year was with the full moon. And so that the animals are timed to these light-dark cycles. They don't time themselves to one smart Serengeti wildebeest, or one smart salmon, or one smart flying fish. These light-dark rhythms synchronize their behavior. And years ago, I did the work, my book Biologic Time. It was probably about 12 years ago. And I worked in cooperation with Oregon Fish and Wildlife, and as well as Washington. And we looked at the outstream migration of the juvenile salmon, and we found that the lowest points of migration were around the full moon, and this is for all the species of salmon for every year. And what happens is that the salmon are timed to light-dark cycles. Salmon migrate when it's dark, and they stop when it's light, just the opposite of us. So if you go to Alaska during the summertime, the first few days, you're going to be out and about. It's almost 24/7 until you fundamentally just drop dead and fall asleep. And these salmon have these same type of rhythms, except they move when it's dark and they stop when it's light. And it's not just the light of the day, but it's the light of the night. And this data is collected from these traps. This is just like a waterfall, and the juveniles get kind of sucked into it. And then in the morning, they take the juveniles out and they count them. That's how they do that. And this is for upstream migrating steelhead. This would be similar to those of the Uruk in Northern California. And so the adults slow down around the full moon. So they move during the dark nights and they slow down the light nights. And that helps them to synchronize their behavior. But it's also anti-predatory behavior to avoid the bears and other animals that are visual predators. And with Oregon Fish Wildlife, we did this, I borrowed their information, we put together this graph. And this is the peak of coho salmon counts around the spawning areas. And every year it was around the full moon. And they were going out on a calendar basis, as Gregorian calendar we have today. They weren't going out on a lunar calendar. If they went out on new half and full moons, this line would be straight up. Okay? And so, but the coho were counted most prolifically around the full moon year after year. And this was out to the p-value was out to the 4th decimal place or something like that. And so there's a continuum. We talked about the Yami, the flying fish set in motion, these other fish. Or we could also say that one event has to succeed another and precedes another as well. And so the salmon, the 12th tradition is they stage in the bays during the spring tides. During the neap tides, which you call your half moons, they're migrating through the estuaries, so the less tidal action. The dark moon migration to the rivers, we found Uruk. The full moon group around the spawning areas, Lobster Creek, for the coho, and they spawn just after the full moon. And when I did this with Oregon Fish Wildlife some 12 years ago, I was out there. And this was just, but it's mainstream now. In fact, it's not as much fun because it's mainstream. And then this is now used for fisheries management, when to release salmon into the rivers so that they're going to migrate. You'd want to put juveniles in the river when it's a dark night, so they're going to move out, whereas if it's a full moon, they're going to settle down and get eaten by the birds. That's the concept. Makes sense. And this all happens, it's tied to light-dark rhythms, but also what the fish eat in both the riverine, the rivers of the mayflies, or in a lake, the freshwater shrimp. And they have these same dark light rhythms. This was done by Norm Anderson, aquatic entomologist at OSU, Oregon State, and published in Nature. And he found that the migration of the invertebrates, the insects in the rivers, was very little during the full moon, but dramatic increases around the dark of the night. And so everything's tied together. Nothing is separate. Nothing is separate at all. Well, this all sounds simple, right? And so you can just predict when the salmon are going to be there. You just look at your calendars and work it all out. It's not that simple. And the reason is that there's a conflict of time. The moon is out of sync with the sun, with the Earth, I should say. And so we have Earth and the sun relationship. So there's 365 days in the solar plus days in the solar year, 29.5 in the lunar cycle of light versus the tidal. So 12 times 29.5 is 11 days short of 365. So the salmon, for example, if they were migrating during the new moon of January 12th one year, they'd be January 1st the next year. They'd be moving back in time. But the salmon can't keep moving back in time because they'd be back into the summertime. So they have to have a way to resynchronize their behavior. So my work sort of brought that out, and people asked the question. And of course, this question hadn't been figured out by indigenous people around the world without knowing the biology, or the chronobiology in this case. And the Tuolip used the white pine butterfly, the Yami used a flying fish, the Uruk used the sun and the moon with the winter time to the winter solstice, but I'm pretty sure they had some animals in there as well. The Thompson used the rutting of the white-tailed deer. The Chukchi was entirely by the caribou, and the Columbia Basin Indians started with the swallows, the arrival of the swallows to predate the salmon, which predate to that was their sundial solar calendar. So that's how they did it. So they timed off other animals, because if one is late, everything is late. If one is early, the other's early. But they're never early or late. They're just on different time. And of course, in the Christian tradition, Easter is timed to is the first Sunday that succeeds the first full moon after the vernal equinox, and that's why Easter moves every year. Okay. And you could actually use the timing of Easter to time the migration of fish. Guess that one, right? Okay. So the big question is, we as Homo sapiens, are we timed to the moon? And every study that's ever been done says no, we're not. Okay. But when we've heard the stories that full moon nights, people out there crazy, all that sort of stuff. Well, the studies will show you that the people that are crazy during a full night were actually crazy during the day. They were just out that full moon night, and that's fundamentally how it works. Okay, okay, and so it's true. It's just they were out and about on those nights. Okay, so then the question becomes: are women tied to the moon? And of course, in the popular lore of women, and in the poetry and the myth, that's out there. And that remains a question, because the women's menstrual cycle is 28 days on average, which is roughly tied to the cycle of the moon. And that raises a big question: did the moon drive the women's menstrual cycle? Of course, the menstrual cycle didn't drive the moon, right? We know that. Okay, but it raises this question, and around the world, this question has been studied around the world, and the answer is that. The closer you get to agricultural societies, it's more women are synchronized to the moon, and the closer you get to hunter-gatherer societies, even closer than that. And there was a study done in the South Pacific, I can't remember which islands, but an anthropologist heard the story of the the Polynesian women were saying that they were giving birth on the tides. And they had the data, and there was only a question about this, and it was in their popular myth, but it was true. And so the anthropologists actually studied the question and counted back to gestation periods and found that they were, in fact, giving birth to the tides. But the reason was because the men weren't there. They were fishermen. So the men were fishing on certain tides and not others, which then drove the women's birth on average. So, and that was was the work. But it still asks this question that 28 days on average is roughly tied to that of the moon. So what's the connection? We are not, as far as anybody knows, we are not physically tied to the moon itself. That there's not the wave action and gravitational forces and all these things. We're not being tied. Well, this also creates a question, is that since the moon is moving away from the Earth, there was a time in our distant past where the women's menstrual cycle was not on average timed to that of the moon. And there'll be a time in the distant future that it wasn't. So maybe there was this window of time in the past that the synchronization of the female menstrual cycle among Homo sapiens and other eight great apes had some significance. Well, the menstrual cycles themselves are quite rare among animals on this planet. They have the apes, some bats, and the elephant shrew. There are 1.5 million species of animals on this planet, and we've got about 50 here, right? And I'm throwing in the elephant shrew, right? Okay. And so if we thought, let's think about another planet. If we think about life on this planet and we project what we know into the cosmos, and we just have these animals with this 20.5, we have these, just with menstrual cycles alone, a very small percentage on this planet, what is the possibility of having menstrual cycle-like animals which have a timing mechanism to the moon and it can actually tell time in the way that we do in other planets? They would have to have that internal mechanism. And I believe that there was a time in our distant past that we were on the beach, and the women's there were the common ancestor of us and the chimpanzee was a female who was picking up the rhythms of the tides, knew when it was, figured out that it was tied to her own menstrual cycle, and then figured out what was the best time to forage or gather on the shore, and that became a three-way clock. You had the menstrual clock, you had the moon clock, and then you had the actually four-way, tidal, and then the food itself. And so over hundreds of thousands of years, many times repetitively, our distant ancestors caught on. So most animals actually come into heat. So let's say the 30 or 40 species that have menstrual cycles, most come into heat. And they come into heat when, or they're ready to breed at a time where, if you start counting the gestation period after that, that's most desirable and most beneficial for the juveniles to survive. So horses, for example, will come into their biological window for conception is starting April, and 11.5 lunation gestation period will drop them in the springtime when there's lots of food. And so the juveniles, the foals will be most protected. And of course, I can find this in a lunar calendar as well, among the Yakut people in Siberia. And the remainder of the calendar from a anthropologist in 1933 was he had the fish spawning in June, and he had the foal he catches in April. Their calendar itself, the lunar calendar, we have evidence was tied to people or horses with the moon. So if we have Native Americans, we have people in Siberia. Native Americans came down, let's say 15,000 years ago. They were in Beringia 25 to 35,000 years ago, because it was sort of like it wasn't a continent, it was a large landmass. Paleolithic cave art is, should I do something?
No, it's from this king spider.
Okay, got it. Okay, I'm okay, yeah. Yeah, I'm okay, yeah. Okay. Okay, that's right. Okay. So we have people on two sides of the Pacific Ocean. The tradition we have in North America is at least 15 to 35,000 years ago. And so it had to have come over from Siberia, where people have that same tradition. So I looked back at the Paleolithic cave art going back to 17,000 years ago and further. Does this tradition maintain itself? And we have these 13 dots here that lead to a box between the legs. It's at the Lascaux cave in the Dordogne region of France. And here we have each of the megalosaurus, or the red deer, and red deer is similar to a elk. We have 13 dots that lead to a box. Okay? And this particular, I believe it's a red deer, is actually in its rutting condition. This is a red deer today. You can see the steam come up in the morning. It's arched neck. We see the full antler set, the same as this animal here, which ties back to the Serengeti wildebeest beginning of the rut at the full moon, as we found by Anthony Sinclair. So biological behavior that's synchronized by these light-dark cycles. And that's the classic. It's the classic ecclesiastical full moon, which of course is the Easter full moon, or the full moon that Easter Sunday is preceded by. Here's the Columbia Basin. We have these 13 dots marks here from the bow hunter. Here's the same one of the skull, 13 dots, leave for a box. This also in the skull, we have 13 marks in the back of this big stag. These ibex have 13 marks here, and then we have a box. They were interested in 13 and the box. And there's more of these. In other caves in Paleolithic Europe, these are prevalent as well. So why would you use a box? Okay. Well, this is the Chinese character for Yue. It means month. And one of these is the two halves of the lunation. Okay. In an entire Chinese calendar, or it's actually not Chinese calendar, in Chinese character system, there are no circles. Okay. Because it's easier to mark lines on rocks or shells, as the ancient Chinese did. So let's go. Let's look at this other animal, this horse in Lascaux, 17,000 years ago. And accompanying the horse, we have this grid pattern. And what's different about this grid pattern is you got that dot in the middle. And if we said hypothetically the vernal equinox was here, and then this would be the dropping of the foal, and this is a pregnant mare. Okay, in the same chamber at this Lascaux cave, we have this ibex, or actually two ibex, and this one's pregnant. And if we go the second lunation, if this is vernal equinox, so April, May, that is when ibex drop their young. That's two. Okay, and we can go to a third one in the same chamber. We have this auroch, which is a bovine, and biologists believe that they bred in the autumn, in the late summer. And so perhaps this is that late summer period here. And of course, this is actually this is all the innards of a bovine. And the calf is here in this white area here. This is the rumen, the area where it's kind of a digestion area. And this is often said to be a leaping cow. And up here in cow country, have you ever seen a cow leap like that? But you've seen animals drop their young like that. And this auroch is dropping its young. And I believe that this is a lunar calendar that is telling when they're dropping their young. I also believe that it's just like the Chinese character of Yue, that the top series of boxes is the darker half of the lunar cycle, and the bottom is the lighter half of the lunar cycle. And so that accounts the two sets of boxes, and why the marks are in the top box as well. So it's time factored. And it might even be part of a sign language. And if we could, because we could count in the same way, from March here, we go the vernal equinox, we get April, May, June, July. And we could count the same type of grid pattern. This particular grid pattern came from the Gorham's cave in Gibraltar from about 34,000 years ago. And that's what the image actually looks like. And you can see this hashtag. Okay? And you can overlap it, and you can actually see the metacarpals on the hand. And it is to scale of a hand. You can put your hand. So this is my hand over that to scale, and it's 50 millimeters. Go back?
Yeah, well, I wanted to see that again.
That one? Yeah. There's,
The one on mobile.
so this is the Gibraltar one.
Yeah.
This is the base image, and that's the overlap. This is actually that grid pattern that you saw in this previous one. It's the same grid pattern here, but it's illustrated, and my hand is overlapped at bottom to top. And you can see, I propose, the same as Lascaux, it's March, April, May, June, July, that they're counting across. That's what I believe. And of course, there's a horse in there. And if that was a gesture language, it would probably be something like, if we do it like this, you'd have the horse's head, the first lunation would be down, as we saw in the Lascaux image, we have the two legs. And then the ibex that we saw would be like, this would be the, actually this goes like this. That would be the ibex, okay? And because the down one would be, the middle one was marked, and then the orc would be like this, with the last 4 down, if it was a sign language. We don't know, right? But chimpanzees have sign languages. So I'm pretty sure these people have sign language too. Okay. So on our journey to discovery, we've come a long way. We came from the Grunion and the California beaches all the way to the Dordogne of France 17,000 years ago. And we've talked a lot about conscious timekeeping. We've talked about animal timekeeping. So the salmon are not conscious timekeepers. They respond to light-dark signals, which help them to escape from predators and find their prey, okay? And also to synchronize their mating behavior. But how did we actually make this leap? And I mentioned earlier that there was probably a common ancestor of us and the chimpanzee that lived on the beach. And living on the beach, that individual or series of individuals, because they could have happened millions of times, and most of the millions didn't succeed. And there was the female menstrual cycle among that individuals were timed to the moon, of course, and the tides, and some sort of foraging behavior on the beach. And it also allowed, by having the menstrual cycle as a clock, that common ancestor could have walked off the beach and found other resources, as opposed to being stuck to the tidal shellfish or those marine resources. So could this happen again? Could it happen on our planet? I believe so. If you had chimpanzees with oceanfront property. And so I believe that it's possible for animals with menstrual cycles that are roughly timed to the cycle of the moon, living by the ocean, could actually evolve to have this, to become, it's a long way from there to where we are today, but to make this great leap forward. And could this happen with Neanderthals and Homo erectus and the rest of them? Absolutely. And when I was in college a long, long time ago, because I'm in my 50s, that evolution was explained by a tree, and that down here was Lucy, okay? And as you come up the tree, you had Neanderthal, Heidelberg, and the rest of them, Homo sapiens. But now we actually see it as these spontaneous combustions. DNA evidence doesn't show that all these homos are tied together. And a way that it possibly could have happened is there actually could have been spontaneous combustions happening over many millions of years on the beaches of these common ancestors. There was a common way that they found to tell time. And of course, if you start moving from the moon, then you step up to the stars and the sun, and that was the presentation I gave last year. And of course, is online on the IFA page. But it's a big step up to the sun and the stars. But that allows you to walk off the beach. It also allows you to walk off the beach without the female's menstrual cycle. Okay, that's important too. So males could go out to hunt without the females. And that ties us, we go back to the Drake equation. And by Frank Drake, one of the founders of SETI. And the Drake equation is commonly used in science as a formula for predicting alien life on other planets. And you can go on Netflix and CuriosityStream and all these sort of places, and they will say, well, we can prove that there are intelligent, or most likely intelligent life on other planets based on this equation. And of course, it's based on factors. And the key factors, the factor of life, FL here, I have no issue with there being life all over the cosmos. Okay, I have no issue with that at all. So the fraction that develop intelligent life, intelligent life as an elephant, I have no issue at all. Dolphins, smart animals. I have no reason to believe there can't be intelligent dolphins around the cosmos. But then we have here, interstellar communication. There's a huge leap between life, intelligent life, and interstellar communication life. Because you have to learn to tell time. How many millions of years did it take us to get off the beach by being scavengers, telling time by the moon, to actually getting to the point of interstellar communication? Now, this is my hypothesis of how we actually got here. And I think we actually need to add a few factors in there to work it out, including the distance between the Earth and the Moon, and if animals on other planets have menstrual cycles that are timed in synchrony to the Moon. Now, there may be some other way that we have intelligent life. I have no idea, and I believe that to move the Drake equation forward in this way, you really need to come up with another way for intelligent life. And if you are an alien searcher out there, this doesn't throw out the Drake equation totally. I would say you want to start looking at planets, places, not just blue planets out there, but blue planets that have a body next to them that could potentially, the animals could tell time. Just as we learned from the Moon, or at least I propose we learned from the Moon. And of course, we have the Fermi paradox, and you had a speaker here a few years ago, and one of the Fermi paradox is, well, these are all the reasons why we're not finding aliens. And of course, we are the aliens, that sort of stuff. But life is extremely rare. And I'm not convinced, I'm not an astrobiologist. And I have absolutely no opinion on whether or not life is extremely rare. But I have a very strong opinion about conscious, timekeeping, intelligent life as being extremely rare. Because it's not just rare, it's rare on this planet. A number of animals that have menstrual cycles, but it's also a certain point in the history of the Earth, because the Moon has been moving, was closer to the Earth, closer to the Earth, and it's been moving away. So we had this, in my view, we had this window of time that this all could have happened, that we could have become conscious thinking people. In many millions of years in the future, if we didn't make that leap forwards, I believe we would have missed our window. But that's just my opinion. And so what would it take? Look in the cosmological perspective. And by the way, SETI hasn't invited me to speak. Okay. Well, we need a blue planet with an Earth, a Sun, and the Moon, in my perspective. And we're out there looking for blue planets right now, or moons, right? And then I believe that we need animals that have an internal type of timing mechanism that could then synchronize to some other body. And the only ones we know on this planet are the menstrual cycle. Okay, the only ones we know. And then a conscious, that you could actually reach to a conscious level. So an animal biological gauge in time with the Moon or another lunar time animal to reinforce the value. So you just can't be timed to the Moon and the tides, but you have to have some fish or the shellfish or that you're learning from the Grunion that you can feed off of to make it more beneficial. Expanding the lunar recognition to other animals, you have to get off the beach. You have to go for the Chukchi, basically living by the rhythms of the reindeer. You can't do that all the time because you're limited to living among the reindeer, which is a herd animal. And the Native Americans worked it out that they would time off of the large ungulate, but then they would use that clock to find other animals and plants. And then you need to finally learn to reset the Moon to the Sun and the stars. And then you actually have a truly conscious timekeeping clock that you can communicate with other people. And you can form societies around to have large common goals. And this probably happened, I'm going to take the Sun and the stars, we know this happened at least 34,000 years ago because we have in the cave art in the last presentation I give. And I believe it's tens of thousands before then. So this is we remember the scene in Contact, and Drummond says to Jodie Foster in so many words, you need to get another job. Okay. And, well, I think it's a pretty harsh statement. And you should go have kids and have an academic career and throw away all this SETI sort of stuff. And of course, a day later, she's listening on the earphones, and she picks up the wow signal, which is pretty cool. So this doesn't mean that if you're an alien hunter, you need to go look for another job. This means that you probably can redefine your search and start thinking about other ways that you could possibly find conscious timekeeping animals. in addition to the menstrual cycle one, because that's pretty rare on this planet, and it's highly unlikely you can find it in other places. And if you do just go off this menstrual cycle type of concept, start thinking about places that not just have moons, but have moons that can be seen from the planet itself. Because if you don't have anything around you, you can't time yourself off of it. Okay. That's a concept. So are we alone in the cosmos? It's less likely than we were the conversation 30 minutes ago, right? Okay. But it doesn't mean that it's not possible. And of course, the Drake equation brings out how many galaxies, and these are trillions of numbers. And it just keeps getting bigger every year with every remote telescope. So are we alone in the cosmos? I believe that there's dolphins on other planets and elephant type of animals. But are there animals that can pick up signals from us or send us signals? That's pretty far down the intellectual chain. And so, of course, that is the question out there. And, in the words of Billy Joel, you may be right, I may be crazy, but it just may be a lunatic you're looking for. And before the show tonight, I said that all the women in this audience are going to get it. And it's a truth. It's a truth that we have among Homo sapiens. And all the work that's in this program was in biological time. I brought forward into before Orion. It actually had many different lunar behavior of animals and recognition by people, hunter-gatherers, and it's the Paleolithic. And I do a lot more onto the sign language. I actually came up with about 20 different signs of animals that follow the same characteristics of the ones that let's go. So it's not it's intuitive. And all my social media channels, and you're welcome to follow. Okay. Questions? Okay. First question. That's a good. Yeah. So there's the question of the Drake equation of with the immense number of planets and solar systems and so forth out there. What's the probability that it's not going to happen? I think that the Drake equation needs to be rewritten with taking the 40 species of animals with menstrual cycles on this planet and relative to the rest of the animals on this planet, and then the window of time that the Earth could have, that the primates on this planet could have actually learned to tell time with the moon, and then so it's rewriting that Drake equation. It doesn't become an impossibility; it becomes a huge constraint on it. So, is there? I believe, but I have absolutely no evidence, and just no Jodie Foster didn't either. That there must be another. If there's intelligent life out there that could actually communicate to us, there would have to be some other mechanism for them to learn to tell time, because this one, as I believe we did it, is so remote, and it's not just within the history of the cosmos, but this planet itself. That in that window of time when the moon was so far away from the Earth that it was in synchronous with the women's menstrual cycle, that the women could actually tell time, learn to tell time. That's my perspective. Sure.
I've always, we're comparing what other intelligent races do, like comparing that intelligent life to us.
Sure.
And whether there's intelligent life out there that is completely different than us, which
Sure.
is way more intelligent than us.
Sure.
And has such a completely different biology, and so do something different,
Sure.
that they do have time telling capabilities internally, but it's not a menstrual cycle. It's completely different. We don't even have to work with it.
Exactly. I agree with that. So the question is, could intelligence develop in a different way in different environmental conditions, kind of as a concept? And the answer is possibly, but you got to put that in the Drake equation. So the Drake equation doesn't have the Drake equation assumes that in our solar system we have intelligent life here, and that so fundamentally every solar system should have intelligent life, at least one. But it's so rare in our planet that if the work of astrobiologists should encompass this work, but start thinking about how other people could develop intelligent life, because the Drake equation projects what's happening on this planet in this solar system. That's in our galaxy. That's how it's projected out. So what we know, we project out to find an assumption of what else could happen out there. So your proposal is highly valid. Is you've got to come up with a different model, and that's what I'm saying is that the Drake equation model itself is too simple. It's a mathematical projection that's not based on biology. Right? Another question? Okay.
To what extent can the genes in our DNA tell time?
There's an entire field of chronobiology, and I could probably talk about for 4 hours just on how we tell time, and your genes tell time. The answer is yes. How it works, we don't know, but there's light receptors along your whole body, or actually it's actually darkness. It's light in the absence of darkness. We actually, when you were in college, you talked about the length of day. But in physiologists and chronobiologists talk about the length of night now, and that the light interrupts the length of night, the daylight, just as the moon can interrupt the night light. And that's what we're talking about here. Okay. And we talk about these Native Americans. They just didn't have one lunation to the next that had a different behavior of the animals, but it was also phases of the moon within that. And so it's the length of night. So there are many light receptors in the body, and the primary organism, as we believe, is the pineal body, which ties into the entire biological clock of the body. But if you turned off the pineal body, other light receptors or absence of light receptors work. And it's a tremendous field, and maybe 30 years ago, a doctor gave you medicine, just take it. But perhaps today, a doctor might say, you should take this when you wake up in the morning, because it have a different effect than if you take it before you go to bed. So in medicine today, it's thought of differently than it was in the past by this concept of biological clocks. Yeah. But good question.
One more. Do you think the viruses are intelligent aliens?
So really, actually, the better question is that can alien life travel from one planet to another, and perhaps through asteroids, right? That's the concept. And the answer is, I'm not an astrobiologist. I can't answer that. But are viruses themselves, they're invasive species? Absolutely, and the same that we are. Yeah. But yes. I would view viruses as a life form that's seeking to appropriate itself.
Because I was always thinking, if you're looking for alien life,
yeah,
you want to bring a microscope with you.
Yes, that's right. A 3D one.
And a
3D one. One more? Thank you.